Welcome to Digital Electronics. Today we're going to breadboard some circuits using Tinkercad. First of all, let's make sure that we are in tinkercad.com and that you've logged into your account. The next thing you have to do is make sure you select circuits instead of the other options that are available there. When you click on circuits, you're going to see the history of the circuits that you've made before, but let's start by creating a new circuit. So the circuits that I want to show you today are how to simulate, or I'm going to show you today how to simulate series circuits and parallel circuits. I prepared a small little circuit here that you can see on my screen. It's just a series circuit with a 10-volt battery and different sizes of resistors. What I want to do is I want to build this on a breadboard. So the first thing we have to do, I'm going to make my window a little bit smaller so we can still see the circuit here on the left, but I can work on Tinkercad. I'm going to use over here on the right hand side a small breadboard, place it in the center of my page. I'm going to then grab a power supply that's 10 volts. The power supplies are not under the basic components. The power supplies are under other components, so we have to click on that and select all. Now we scroll until we find a power supply. You could also search for it, but I'm going to show you where it is down here. Here's a power supply. Put the power supply, place it down. Now, what we have to do now is grab a few resistors, 3 to be exact. Resistors are at the very top over here. I'm going to place them right here for now because I'm going to show you how to connect them and place them on the breadboard. I'm going to close the components window so that I can then zoom in a little bit more on my breadboard. Now, what I would like to do first of all is connect the power supply to my breadboard. So I am going to connect the positive side to positive. I'm going to click number 2 so that it changes my wire to red and black. 1 is for black, 2 is for red, just to keep standard. Now I am going to organize my resistors, and I want to make them look almost identically to the schematic. So this first resistor has to be 1K, and that's what it is by default already. What I'm going to do is I'm going to rotate it so that it looks horizontal the way it's on the schematic on the left. I'm going to place it on my breadboard right about there. Now notice that the left side of the resistor is connected to the positive side of the battery. So what I'm going to do is I'm going to connect from here to the positive side of my battery. Click 2 so that the wire turns red. So the positive side of the battery is coming in here. It goes through the resistor. Now this other side of the resistor is connected to the top of the second 500 ohm resistor. So I'm going to make the second resistor 500 ohms. Notice the colors changed, and I need to connect it on the same clip. There's different ways to do it. The simplest way is to connect it across the channel, because now as you can see the electricity would flow and that same clip is making the connection. You could put it farther this way, but then you would need to connect the wire to make that connection in series. It's either way, it's however you prefer. You could also do from here to here, and then and then I would move from there to there, and it looks more like the wire. Whichever way you prefer. It's actually a good practice to have as few connections as possible, only to reduce the quantity of possible errors in connections. But this software, it will tell you when there's an error. You'll see it immediately. So whichever way you prefer. This last resistor would go down here, and that's 2.5 kilo ohms. So 2.5. Oh, I don't type the letter K. I just leave it like that, K. Very good. I rotate it by pressing R, and I connect it to the same clip as this other resistor. And the negative side goes towards the negative size of my battery. So there is my series circuit that is going to be simulated. At this point, my simulation won't do anything. It just tells me how much total current's being drawn out and the voltage. Oh, which I forgot, it shouldn't have been 5 volts. I need to change that. It should have been 10 volts. Okay, so let's make sure we put that to 10 volts. All right. So now my simulation tells me it's 10 volts and it's 2.5 milliamps of current coming out of the power source. But I want to know how much voltage and current is used by each of the resistors. To do that, I'm going to finish using this drawing, so I'm going to maximize it so you see it better. So what I'm going to do now is I'm going to get a multimeter to measure current and voltage. And the multimeter is right here next to the power supply. I'm going to place a multimeter right there. Okay, so here's my multimeter. Notice that the multimeter has a negative connection, a positive connection. It measures amps, volts, and resistance. For this circuit, I want to measure the voltage. So I'm going to leave it at plus voltage. I want to measure the voltage that goes across this one resistor. Remember that to measure voltage, we need to connect the voltmeter from one side to the other side of the device and making sure that the terminals are correct. For example, this negative terminal should go to the other side, but let me connect it wrong so that you see what happens. So I'm going to make that one the red, the red and black. So because this is the negative and positive. If at this moment I run my simulation, notice that this device uses 2.5 volts, but these wires are backwards because I'm getting a negative reading. So that's not the correct way to measure. What I need to do is I need to swap the wires so that the reading is correct. To swap my wires, I have to kind of put a placeholder right here, and I move this one this way and the black one to the right. So now what you'll see is the positive measurement goes towards the positive side of the battery, and the negative probe measurement goes towards the negative side of the battery, like that. Now if I press play, it's going to read a positive reading. Let's measure the voltage, and I could do this on the simulation. It doesn't affect it much. I'm going to get a multimeter per each device so that I can measure all the voltages at the same time and show you. So I'm going to put this multimeter down here for the bottom one and this one about here for this middle one. So this negative terminal goes towards the negative side of the battery. I'm measuring the voltage across this device. I don't like that wire being kind of, so I'm going to go like that to get it out of the way. And then this wire is going to go and come over here to the right, to the top. So notice that this voltmeter is measuring across from top to bottom, or before and after this resistor. Be careful, some people make a mistake and put it right next to it, but that's not connected. You need to make sure that the connection's on the same clip. So if I then press play, it's going to give me the voltage of the second device. Okay, notice that I have 10, and so far I've used 3.75, so we expect the remaining to be used by this last device. So the positive side, the positive goes towards the positive side of my connection, so I need to connect it to there, and the negative one goes towards the negative side of my battery connection, but again across this device. Now if I start my simulation, you will see that the voltage here, 10 volts, is the sum of all the voltages. As Kirchhoff stated on series circuits, the voltages do add up. 6.25 plus 1.25 is 7.5, plus 2.5 is 10. So that is how you would measure voltage in a series circuit. Now, I'm going to stop the simulation and delete these, but what I want to do is now show you how to measure current in a series circuit. Okay, so my circuit is complete, and the good thing about this simulation is that it tells you the total current already, right? And we kind of should know already that the current is going to be the same, but let's verify it. Okay, now I don't want to measure voltage, so the first thing I have to do is click on my meter and change it to amperage or current. Now, how do I connect it? I do not connect it across. Again, I do not connect it across each of the devices. To measure the current, your circuit has to be broken and the meter has to be part of the circuit as if it was another component in series. So to do that, I'm going to break my circuit. Notice what I did here. I just took my resistor. It's still connected down here, but I broke the connection at the top right there. So now what I have to do is I need to put the meter in series. The cool thing about here is that if I was in actual breadboard, I would extend the leg, but I cannot extend the leg of this resistor, so I'm just going to connect it there in the middle of the air. So now my electricity is going to go from, there it goes. So imagine, follow my mouse, and I'll show you the path that the current would take. So the electricity comes out of the power source in the red wire, goes through this clip. It goes to the red wire to the first resistor. It goes over the first resistor. It then goes through the meter, back out of the meter, touches this resistor, goes over the resistor. The resistor is connected on the same clip as this one, so the current has to go through the resistor back to the negative side of the battery. So as you can see, the meter is now in series or in the same wire as the rest of the devices. If I press play, notice that I get the same current. If you get the same current as the total, that means you did it right, because in series there's only one current. Now, I chose to do the current measurement at the top here, but I could have done it, broken the circuit here at the start, at the bottom between the vertical and horizontal bottom resistor, or at the bottom over here. So no matter where you measure it, you should get the same current. All right, so that is for a series circuit and how to measure voltage and current. Now, I would like to show you how to do the same measurements in parallel, because they are not done the same way as in series. They're slightly different. So what I want to do now is I'm just going to rotate these resistors and get them out of the way. I would like to build a parallel circuit. Now, if you're building a parallel circuit, if you remember, you don't have the components the same way. You have different branches. So for parallel, I'm going to rotate those. And the way that it looks like in parallel is that you would have three, or I'm going to use three branches. So the components would look something like this. Okay. So as you can see, there's only, all the devices are connected to the top of the battery. So what we have to do is just put the battery, which I already have here waiting for me, right? I have the battery, and I need to connect the battery to the top of each device. So what I'm going to do is make it look as close as possible as the picture on the left. So let's do that. I'm going to take my resistors, and I'm going to put the 1K right here on the right. Actually, these numbers, they're going to come out a little bit ugly in parallel. So what I'm going to do is I'm going to make this one also 1K. I'm just going to make them all 1K because the voltage is going to be the same. We already know that. What has to happen is that the current has to add up. So I'm going to make them all 1 kilo ohm for this example. So this is a 1 kilo ohm resistor. Yes. I'm going to delete these other two, and I'm going to copy and paste, Control C, V, Control C, Control V. Now, all I'm going to do is I'm going to put my resistor vertically, just like this, and I'm going to connect from the battery to that. Notice that the battery is connected directly to the top of that resistor. The second one, I'm going to connect also, I can go from the battery all the way. No, I'm just going to go from here to that resistor. And the last one, I'm spacing them out just to make it super obvious, but you can make them a little closer, I guess. And the last one connected to there. So as you can see, all the resistors are connected to the negative wire the positive wire from the top, right? Now on the bottom side, I'm going to do the same thing. I'm going to connect it, but this time, I guess I'll use black wire, and then I'll connect that one and that one. So there you have it. You have 3 resistors connected in parallel. I find that that's the easiest way to connect resistors in parallel. Our voltage is still 10 volts, and the current is set to maximum of 5, but it's going to depend on how much this voltage and current draws from the devices. Okay, so that's how you would build it. But now, how do you measure voltage and current on a parallel circuit? Okay, well, let's measure voltage first. So I clicked on the meter and I selected voltage. So remember, voltage you have to measure before and after each device. I'm going to rotate this one to put it, actually, no, it's not going to work out. I'm going to rotate it a little more. There. It doesn't matter. Yeah, no, that's not going to work on this device because it doesn't flip the reading, and so it's going to be upside down. So to measure voltage, you need to measure from one to the other. So you can measure, let me show you the 3 different ways that you can measure voltage. You can measure voltage from there to there, and because you're measuring across this device, and you're going to notice that it's 10 volts, right? You can measure voltage from this top device to this one. Notice I'm just measuring across this resistor, and it's going to measure 10 volts again, because it's all the same connection, as you can see. So this one, you could put 3 meters, but there's really no point because they're all going to be the same measurement. So I'm just wanting to show you that all the measurements, no matter where you take it across each one, is going to be 10 volts. So that's how you measure voltage in parallel. You have to just measure across, but really there's no point in measuring multiple times. Just measure once. I probably do this one like that to verify that my voltage is 10 and it's connected properly. Okay, now how do you measure current in a parallel circuit like this? Well, remember, to measure the current, you're going to have to get in the wire. You have to break the connection. So what we want to do is measure the current that's going through this resistor, only through this resistor. So what we have to do is we have to break the connection either on the top or on the bottom. I'm going to do it on the top only because there's a little more space. To break the connection, I moved the resistor a little bit. Notice what I did there. I moved the resistor. It's still connected in the bottom section. I just gave myself a little more space. So this right here, this top part of the resistor should be connected to this clip, right? So there's a gap right there. So that gap is going to be fixed filled by making this an ammeter and connected it to connect that gap. So the positive side of my meter is going to go where the location where the resistor was before, and the negative side of my meter is going to go to the other side. So now what's going to happen is the electricity or the current is going to reach this clip. Instead of going right through the resistor, it's going to go through the clip. It's going to go through the meter, red wire, down the meter, go through the resistor and back out. So notice that this amp meter is now in the same wire as this first resistor. Let me get another one, Control C, Control V, and another one for the third one. So what I want to do is just measure all the currents at the same time. For this one, again, you break the wire, and connect it from where the resistor was to where it is now. So I'm going to take my positive wire, and this is where the resistor was, and my negative wire goes, this one should be red. There you go. So again, the electricity would go through here, it'd go through the meter. Oh no, I connected it to the wrong place. What was I thinking? It goes to this one. My mistake. So now the electricity would go through, I don't that's covering. There you go. So the electricity comes from here, goes up the meter, down the black wire to this resistor. And the last one, I leave a connection to the bottom. Notice that's not broken. The last one, I connect the positive side to where the resistor was, which was right here, right? Oh. And then the negative side to the resistor. Let's check to see if we did it right. So because they're all 1K, what's going to happen is that they're all going to have the same current. So each one has 10 milliamps. And notice that the total current is 30 milliamps. So we are measuring properly. In parallel, the currents add and there's only one voltage. While in series, there is only one current and the voltages add up. Now, the last part is what do we do if we want to simulate a circuit that is a combination of series and parallel circuits, such as the one that I have on the picture on the left. So let's start from the beginning. Let me remove all these devices and let me move the resistors out of the way. So what we have to do now, is place the components again to connect them and make them look as close as possible to the circuit that's on the picture. So, I keep clicking on the wrong place. There we have it. Here, I'm going to have my circuits. I'm going to minimize this so that I can see both at the same time. So I'm going to have the battery. My battery is still in the same place. I'm going to connect, and I just left 1K resistors for simplicity, but I have to connect this resistor to the positive side of the battery. So I connected, as you can see, right there. The second, or the right-hand side of this resistor goes to two places. It goes in parallel to a branch over here and in parallel to this one. So I'm going to connect first to this bottom one. Notice that this would be the equivalent of this vertical resistor, and I'm going to connect the other one on going towards the right side like that. So that is connected. The other resistor, I'm going to do Control C, Control V, would be connected, as you can see right here, and there is no resistor down here, so I'm just going to connect it with a wire. Sure, I know this is not ground, so I'm going to use a different color. There, green. I don't want to make it black because it's not the negative connection. But I do have one more resistor that goes from there, from this connection. Oh, I can't fit it. Let me move the battery a little bit higher so that then the resistor connects. There it is. So as you can see here, you have the battery, the current leaving the battery. It goes through the first device. The current splits. Some of it goes down to this resistor here, and some of it goes to the right and through both resistors. As you can see here, it goes and it comes back down. There's just a wire, and then it joins to the connection where the second node is down here, and it goes through the resistor back up to the negative device. To measure voltage and current, now it's the exact same thing. The meter, you measure across each device, and to measure current, you lift the device and connect the multimeter to complete the circuit. And make sure you don't forget to change the meter to measure volts or amps, depending on the measurement that you're making. I hope that was helpful. Until next time, I'll see you later. Ta-da for now.